All right, geometry 12.4b. So the second section of vectors. So last section we talked about vectors. We talked about the magnitude, which was the absolute value of the vector, or essentially how do we find that? We did the Pythagorean theorem, right? And then we found tangent that gave us the degree of that vector, okay, which was the direction. Now what we're going to talk about in this next section is something a little bit different, and that is called vector sum. So essentially is if what this is if we're going to add two vectors together. Well, this makes kind of sense here, right? If I have two vectors and I want to add them together, what do you think we have? We are going to have a common vector, correct? So what will happen, so if I have u and I have v, so those are our two vectors, u and v. Remember, u is the arrow A, right? It would be AU and BU. And vector v is AV and BV. Okay, so there's our two vectors. Now, if I want to add those together, I would just simply add AU plus V, BU plus V. Okay? So I can add those two things together, and that's going to give me my answer. Okay? So, now, if I add those together, I will get specific answers for this. Okay? Those specific answers are going to be, all right, very similar to what we've already talked about. So if I have a drawing, okay, it looks like this, and I have my first vector, my second vector. When I add those together, I'm going to end up with that vector. Does that make sense to everybody? Okay? So is everybody following that? So this would be U, this would be V, and then this would be the addition of those two, which is going to be R. All right, so when you get, what's your final answer of that? Well, it's going to be very simple. You're adding them together. Just simply adding these two numbers together, that's going to give you what that vector would be. And if you want that amplitude, you have to do the Pythagorean theorem. Okay? So let's do a practice problem. U -4, 1. Vector V is going to be 6, 3. So what do? Very simple. Add them together. -4 plus 6, going to give us what? 2. Good. So we're looking for R, 2. And 1 plus 3 is going to give me 4. So my ultimate R is going to be 2, 4, okay, when I add those together. All right? Any questions? So if I were to draw them for you, -4 and 1, and then add 6, 2, 3, 4, 5, 6, and 3. Okay? I'm sorry, 6 and 3. So this is going to be vector 2, 4. Okay, so when I add them together, that's all I'm doing, just adding them together. Any questions? Now, the next thing it says, the next example they give is what's called a scalar product. Scalar product. Well, first off, what's a product? Product is multiplication, correct? Multiplication. Scalar means what? Okay, they're a certain scale. The scale is k, or constant, all right? Your ratio, okay? It says the scalar product of a real number k, v is equal to a, b is kv. So in other words, all I'm going to do to this vector is if I multiply it by something, whatever I multiply it by, it goes through the entire vector. Okay, it's just it's going to change the scalar value of everything equally. Okay, so here's an example. Given we have our u, 2, -4. All right, and v is 1, -3. And they say find 1/2 u minus v. So that's what they want us to do. So first off, if I want to do 1/2 of u, what would that get me? So if I do 1/2 of u, it's going to be 1, because 1/2 of 2 is 1. 1/2 of 4 is -2. So subtract that from 1, -3. So what does that give me? 1 minus 1 is 0. -2 minus a -3 is 1. And there is your answer to that. Okay? So all you're doing is adding them together. Scalar factor is you're multiplying that into both the A and the B. So let's do another example problem and then you can get working on the homework, all right? The example is this. A small seaplane flies at an airspeed of 230 miles per hour with the heading of due north. If a steady wind is blowing from the west at 45 miles an hour, determine the resultant speed and the direction of the plane. So now, we're looking for the direction and the speed, right? So let's start with this first thing. It says this. The first plane says it's going 200, a small plane flies, okay, flies at 30 miles an hour with a heading of due north. So straight north, 230 miles an hour, right? Then it says, if a steady wind is blowing from the west, okay, so in other words, blowing this way, blowing from the west, 45 miles an hour, determine the resultant speed. All right, so this one's this way, and this one's this way, 45. Okay? All right, we need to find the resultant. So, 0, 230, and 45, and 0. What do I get? Adding those two together, because this is P and that's W, we'll add them together. What do we get? 45, 230. Good. Now what do I do? I need to find the R, right? What now I'm looking for is this line, right? I'm looking for the R. So what would that be? 45 squared plus 230 squared equals R squared. Right? Do the math, and we get R squared equals 234.4. 234.4 miles per hour. Okay? Now what do we need? We need this theta. Well, how do we find that theta? Tangent. Okay? So we're going to find this one right here. So what do? Tangent x equals opposite over, okay, so then it's going to be x equals tangent -1, 45 over 230. And when I do the math there, I get 78.9 degrees. Okay? 78.9 degrees. Whoop. All right. And the reason that is because, I'm sorry, I made a mistake. It looks like this. We're looking for this distance. This is 230. This is 45. So it's going to be opposite opposite over that, okay? All right, opposite over the adjacent, okay? All right, so let's go ahead and get working on those second sections of homework, all right?